welcome to your maths lesson for today, which, as you can already see from the screen, is going to be carrying on from where we were yesterday. Yesterday you were adding and subtracting fractions where the denominator is the same, and you've aced that. So now we're just going to focus on adding fractions, but adding fractions where, as you can see, the denominators are different. Now, first things first, this relates to half of the work we've been doing over the past week and a bit. We were looking at comparing fractions, finding equivalent fractions, where we have to change the denominators and the numerators to get comparable denominators, common denominators, and that is what we need to do today. Okay, so if we have a look at our first question, it's 2/5 add 4/15 equals, we can't add those together because we've got fifths and we've got 15ths. So the first thing we're going to have to do is to find that common multiple of 5 and 15 that can become our common denominator. So we can go 5, 10, 15, 20, and then we can go 15, 30, 45. Now the reason I've only done that is because I'm sure you agree with me, you can see straight away that 15 is our common denominator, our common multiple, therefore common denominator. So we're going to be looking at making both of these fractions out of 15. However, we can see that our second fraction is in 15ths already, so we can keep that as our 4/15ths. But we need to establish what we do here. So we have to remember, what do I do to go from my denominator of 5 to my denominator of 15? Well, I multiply by 3. And because I multiply that by 3, the rule, whatever I do to the denominator, I do to the numerator. Therefore, I have to multiply this 2 by 3, which gives me 6. I can therefore quite simply do, as you were doing yesterday, 6/15 add 4/15 is 10/15. So far, so good. So let's have a look at this next one. 1/4 plus 3/20. Okay, again, we haven't got the same denominator, so we're going to need to find a common denominator. So I can list my multiples: 4, 8, 12, 16, 20. Well, hang on, 20. Well, if I do my multiples of 20, well, look at that, 20. So up here we knew 15 was our common denominator because it's a common multiple. Here we can see that 20 is our common multiple. So we can make both our new fractions as 20ths, but as with the first example, you can see our second fraction was already in 20ths and therefore remains in 20ths. It's just this fraction therefore over here that we need to figure out. So what do we do to our 4 to get to 20? Well, we multiply by 5 because 5 times 4 times 5 is 20. So therefore I do the same to this numerator, because whatever I do to my denominator, I do to my numerator. 1 times 5 is 5, and therefore 5/20 add 3/20 equals 8/20. Okay, so we're going to look at another 2 examples. Now for these 2, if you're starting to feel confident, I'd pause the video, have a practice on these, and you can play the video. If not, as I'm going through this, make sure you're saying out loud the steps you need to take so that you can show you've got this confidence. Okay, so we know that we need to, in adding 3 7s and 2 6, find our common denominator, which we do not have. So I can list my multiples: 7, 14, 21, 28, 35, 42, 49. Okay, now I can do the same with my 6. So 6, 12, 18, 24, 30, 36, 42. Well, hang on. I can see that I have 42 here and 42 here. So I'm going to make my common denominator on this 42. Now, a quicker way for this example to have reached our common denominator would be to have done 7 multiplied by 6. Because we know 7 multiplied by 6 is 42. And that's why that just happens to be the first common denominator, common multiple and common denominator that we can have. So quickly, we can 7 times 6 is 42. We now then obviously need to establish this pattern. So here, to go from 7 to 42, we've had to multiply by 6. So we do the same to our numerator. So 3 multiplied by 6 is 18. We then over here established, well, to go from 6 to 42, I've had to multiply by 7. And I therefore have to do the same to my numerator. So 2 multiplied by 7 is 14. I can then do 18 42s add 14 42s, which gives me 18 add 14 as 32, and then my 42s remain the same. It's 32 42s. Now obviously in this type of question you can see with an even numerator and even denominator, some of you, if not all of you, potentially want to have a go at simplifying that down into its simplest form. Let's just have one more look at this final example. So 4 9ths add 5 11ths. Well, I'm not going to worry about listing my multiples here. I'm just going to do my 9 multiplied by 11, which shows me that I'm going to have a common denominator of 99. So I'm actually doing 99ths here. I then established a pattern, as we know by now. So what do I do to 9 to get to 99? I multiply it by 11. I therefore do exactly the same to my numerator. So 4 multiplied by 11 is 44. Over here, I have my 11 going into 99. Well, 11 times 9 is 99. So then I have to do the same to my numerator. So 5 multiplied by 9 is 45. I can now go ahead and add these together. So I know my common denominator, 99, means, well, my answer still remains with 99. And then I do 44, add 45. Well, we know 40 add 40 is 80. 4 add 5 is 9. So I have 89 99s. And this is how you do your adding of fractions. So again, watch this video as many times as you need to see how to do it. You have to have the common denominators and the conversion with the numerators under the rule. Whatever you do to the denominator, you do to the numerator. When you've done that, obviously you've got your choice of A or B. Obviously, if you're feeling confident, do push yourself on B. Please don't take the easy route with A, as you would, because you wouldn't do that in class. Okay, and when you've done that, as always, you've got your thing, you explain, and your solve. So your thing, you have 2 calculations here, 2 equations that you need to complete. 5/16 add something 8 equals 15/16. Well, your odd one out is the fact here that you have 8. So consider that relationship between, what if that was suddenly in 16ths to match? How many 16ths would that be? And then simplify it into that 8th form. Likewise here, something 20ths add 7 tenths equals 17 20ths. Okay, the answer here isn't 10, because you might see 10 add 7 is 17, but you have to remember here, look, we're dealing with 20ths, but here with tenths, because to add you have to have that common denominator. On your solve, and you solve this calculation, 3/4 add 3/16 is equal to 3 add 3, 4 add 16, therefore 6/20 equals 3/10. Can you spot and explain her mistake? So you might decide to work this out yourself in the first instance to see what answer you get, but make sure you take that step to obviously work out where she has gone wrong and explain. Okay, and you can show us visually, practically, however, show us how she's made that mistake. Then on you explain. 2 children are solving 1/3 plus 4/15. Eva starts by drawing this model. Alex starts by drawing this model. Can you explain each person's method and how they would complete the question? Which method do you prefer and why? Okay, so think Eva's drawing her model in thirds. Alex is drawing his model in 15ths. Whose is likely to help them out complete this third add 4/15? Think about what you would do if you were just solving that question without any visual model, and that will help you in terms of explaining here. Obviously, come 10 o'clock, we'll have a look at elements of this. We'll go over a few more examples. If you've got any questions, you can ask them. Obviously, anything beforehand, do make sure you ask Mrs. Williams or I. Okay, good luck with this, and we'll see you at 10.